Okay, seems to be working. We're good. Okay, here we go. Look, so you can learn as much as possible from this problem to help you with the test. I'm going to start with the ones I know are wrong, and the ones that typically trap people. This one is the most dangerous right here. And it relates to what we just talked about. It says f is not differentiable at x equal negative 1. So I come up here to x equal negative 1, and I look at this right there, and that is definitely a corner. That is a corner on the graph of f prime. Okay? If that were the graph of f would not be differentiable at x equal negative 1 due to the corner. But this is not the graph of f. This is the graph of f prime. So the corner on f prime means something else. It means you can't find the slope of f prime. So f prime is not differentiable. That doesn't necessarily mean f is not differentiable. So far? Okay, please.
So f would have to be differentiable because there's a point that makes one of it.
Let's celebrate.
I think it's for everyone.
No, for you. All right. Here, maybe something. Perfect. Look, here's what Caden saw perfectly. Right here. Let's put some scale on this thing because there's no numbers, just so we have something to talk about. We'll call this 5, we'll call this 10. So, Caden, what's the XY pair right there that I circled?
-1 and
Perfect. Hands up everybody now. What does negative 110 mean? Okay, on the graph of f prime, negative 110 is a point. But what does negative 110 on the graph of f mean? What does the negative 110 here mean on the graph of f? Let's go, Scarlett.
On f, you won't be able to find the point. Anything undefined?
2 points, but no, it's okay. Hands up. Hudson.
it means that x equal -1 on f, the slope is 10.
Perfect. You knew that, 2 points. This point on f prime is telling us the slope on f. It's saying at that x coordinate, the slope of f will be 10. So as Caden said, the slope of f is known. This graph has no missing points, no missing y values. That means f was differentiable everywhere. Like we found a slope everywhere on f, and we created a whole new graph to illustrate that. So f is completely differentiable. F prime is not differentiable at the corners, but f is differentiable because we have points everywhere. Question? Whoa. Something else you might do, I've seen people have success with in past years, is as they're listening, if they're like, oh, I got it now, they're good, they just move on. But if they're like, I don't got it yet, but I'm a little hesitant to speak up in class, which is very normal, they just make a note. They're like, I gotta go ask about 30 again. And then they just come and ask about 30. So I can promise you this. If you can find a way to have your schedule allow you to do your homework here instead of at home, you'll spend less time, you'll be way less frustrated, and you'll score way better. Because you will never get mixed up. Like as soon as your brain says, I don't think I got it, you can ask me or a friend or somebody, and then you figure it out. You just keep building on more and more solid foundations. Anyway, you're always welcome to just come here and work. So this one, this is a false statement. F is differentiable. We in fact know the slope of f at x equal 10. Sorry, at x equal -1. The slope of f would have to be 10 if our scale is correct. Questions? Reading. F has a local minimum at x equals 0. Okay, you will have, I think, at least 3 questions on the tests on Monday that are going to try to figure out if you really understand local minimum or not. So you're looking at f prime, so hands up. What would you have to see on f prime at x equals 0 in order for f to have a local minimum at x equals 0? What would you have to see on f prime, this is f prime, at x equals 0 in order for f to have a local minimum at x equals 0? About half of you. That's better. Let's go lay it. So we would have to see f prime changing local minimum, don't get it backwards, from negative y values to positive y values. That's how f prime would have to change. The way I remember that is I use Danica's chart, and I have memorized that if f has a local minimum, that means f is going to do this. F is going to change from increase to decrease. And I can see when that happens by simply observing when f prime changes from positive y values to negative y values. At x equals 0, oh, I got it backwards, sorry. That was terrible. That would be local max. Don't do that. You'll say it's true when it's not. So it's decrease to increase for local min, negative to positive. What they gave us is completely backwards. These values of f prime are positive. These values of f prime are negative. So f has a local maximum at x equals 0. It is a trap. Questions? Okay, so I always have to check. If it's feeling like boring, you need to do something new, you wave at, do this. Look. If you want to keep going, you wave. So I keep talking to like, I'm bored, I want to move on, don't wave. So who wants to keep talking about this? Okay, good enough. Okay. C. F is increasing. Hands up, everybody. What is it about the graph of f prime that will tell you whether or not f is increasing? Hands up. What is it about the graph of f prime that will tell you f is increasing? Go, Izzy. Just don't say it. It makes me blush and feel bad. There we go. Good job, Izzy. So I look. Okay, if your hand was raised, give yourself 2 more. I look at negative, so 1 to 2, right here. Oh, wait a minute, f prime's negative. That means f would be going down. So they messed you up again. This should have been decreasing. Trap again, for sure. Questions? Cool. Item A, we've already done this. F is decreasing when f prime is negative. Nope. I hear f prime is positive, so that doesn't work. That's why the correct answer is B. Please, everyone.
With that, like, by process of elimination, I figured out it was B. But with the slope at the top, they're all
You good now? 2 points for talking through it. Well done. Anybody else? Please.
How do we know that f is increasing from negative 2 to negative 1 if f prime is just a straight line right there?
Perfect. 2 more for Scarborough. So remember, the values of f prime are telling us the slopes of f. So I'm going to change the scale to make it easier to talk about. We're going to call this 1 and this 2. Put a dot right here. The xy pair of that dot is negative 2, 2. Everyone raise your hand and tell me what is negative 2, 2 on the graph of f prime telling you about the graph of f. What is that telling us? Negative 2, 2 on the graph of f prime tells us what about the graph of f? Kimber?
X equals 2, the slope is 2.
So at x equal, you're good. At x equal negative 2 on the graph of f, the slope is 2. So if I were drawing f, I'd come to negative 2. I would have to draw a slope of 2, which is maybe about like that. 2 points if you knew that. Questions? Now we move over. We go to this point. That y value is still 2. That means on the graph of f, the slope would still be 2. So that's like this. Or if that had, like the slope on f is always 2 until I get to x equal negative 1. So this is my picture of f. F has a slope of 2. That's why f is increasing, because slope means rate of change. My rate of change is my y value changes by 2 every time my x value changes by 1. That's what a slope of 2 means. It's a rate of change. Change in y over change in x ends up being 2 to 1. I don't know if that answers your question,
Well, what would it just look like from -1 to 0?
for the graph of f.
Yeah.
So then right here, the slope of f is now less than 2, but not a lot, just a little bit. But then the slope of f gets more or less than 2.
So it's just going to keep increasing, but like concave. Concave down.
Okay, down. Because okay, it is challenging. It's hard for me mentally as well, because you're keeping track of a whole bunch of things. In this region here, just say it as a class. Is f prime positive or negative? Say it. Positive. That means even though the f prime values are going down, because the f prime is still positive, and this is why I'm just going to keep steering you to Danica's chart. Like doing this without the chart can be done. Like every class in the world except ours does it, but it's a lot harder because your brain has to manage a lot more. The understanding of where the chart came from is important, but once you understand, using the chart is really smart. We know that f prime is positive, so I have to keep drawing f going up. But the values of f prime are decreasing. When the values of f prime decrease, that means the shape of f is going to be concave down. So, and it happens because I draw a slope that's a little less than 2, a little more less than 2, a little more less than 2. When I get to here, the slope of f has to be 0. So it's something like that. Now the slope is a little negative, more negative, more negative, more negative, more negative. So we've done that. And right here, the slope is now quite negative. So it's kind of doing this kind of a thing. But now the values of f prime are increasing, which means the slopes of f are increasing. That can only happen if f switches back to concave up. When I get to x equal 2, f's got to be flat again, because this value of f prime is 0. Therefore, that's got to flatten out. That's a pretty good drawing. That's not bad. You can do this, but it's just so much more time-consuming than just using the chart. It's like this. Oh, sorry. Can I look?
Are we allowed to reference the chart on the test or no?
No. So the AP test does not allow any 2 for calcs. Good question. The AP test does not allow any sort of notes. It's all in your head.
I was saying for our test.
Oh no, I totally get that. Yeah, I was just getting that. So the AP test doesn't allow notes at all. So if I let you use notes today, we're just procrastinating the day of judgment. Yeah, it's not helping. It's far better if I just say, no, you've got to have it memorized now, because you'll need it for test 1, you'll need it again for test 3. So. Oh, please, Garrett.
We would be able to draw from memorization to draw.
Oh, yes. Hey, look up. Something that's completely legal is I hand you the packet, and you say, I have a hard time remembering a few things. I'm just going to write down Danica's chart right now. Totally legal. You can write down all you want, as long as it's coming from your head. Even on the real AP test, you're going to walk in the maroon gym. There, you can have your Chromebook. You can sit at your little table. You can ask for 8 pieces of scratch paper or whatever you like. And that takes a lot of scratch paper for the AP test. When I talked to the coordinator, they're like, oh yes, we're allowed to give you 1 piece of, I'm like, what? 1? Like she called the people like, oh no, you can give as many as I need. So. Okay. So you get your stack of scratch paper. At that moment, you can write down all you want. as long as it's coming out of your head. There we go. Okay, I'm excited about something now. I cannot remember what it was, but oh well. Oh yeah, I got it. Look up. Did this with Izzy at lunch. Raise your hand if you can tell me what is the new one? 9 times 7. What is 9 times 7? So Cal, 63. How many new? 2 points. Okay, Cal, do you understand that 9 times 7 actually means 9 plus 9 plus 9 7 times?
Yeah.
Good. You know that, right? When I asked you to figure out 9 times 7, did you go 9 plus 9 is 18, plus 9 more is 20? Did you do that? No, you just memorize the fact. Danica's chart is the same. Okay? It really is important that you understand where this came from. Just like 9 times 7, that's useful at some point. But once you know where it came from for the purposes of our test, this is a tremendously valuable shortcut. It allows you to analyze things much faster with less error. So, she did a great job of coming up with really useful tools. So, questions? Yeah, please. Yeah.
On the chart where it says for the F prime, there's the country down and country down. Is that great? Doesn't it work?
Oh, good question.
Why is it grayed out? And does that help us find a double prime?
Awesome. 2 more for him. The reason it's grayed out is this. I labeled this column. Somebody can answer this question. We take away these labels. That was fun. Okay, we take away the labels. Look, guess I don't have a question. We take away the labels, we can put in our own labels. We could call this column F prime. It's not going to let me. This column is F. Come on. This column is F prime. There we go. I'm writing in white, but it didn't help. We can label the first column F prime. That means the next column is the derivative of F prime. F double prime. Now the third column is F triple prime. Because the columns aren't what I would call absolute, they're relative. Their relationship is with each other, not with anything absolute. So this little part here, Hannah, is just a repeat of this right there. See, I had F prime over in this column, and I had F double prime in this column. It's no different. So it's still valid. It was just me showing you that this little staircase pattern goes on forever in both directions.
So if I have I guess we're not using F double prime some, but if I had F prime and country dot, that does help with the F double prime.
Mm-hmm. Yeah, like I have seen this on the AP test. They that's fun. Look at that. They'll call this. They'll ask you a question about the acceleration of something. Okay. Well, acceleration is actually the second derivative of position. So you might be tempted to put the A of t over here, which we will do in some problems. But in some problems, it's going to make more sense to put it in the first column, because they're then going to ask you about like the derivative of A, which would be this column, A prime. So it really doesn't matter. So, answer your question, Hannah?
Yeah.
Please, Julia.
So if the first column says F prime, and the one to the right of it is F double prime, F double prime is the derivative of F prime.
Mm-hmm.
What is F to F prime?
F to F prime would be F prime is the derivative of F.
Okay, so you can never refer back to
Oh,
something.
looking at backwards.
Yeah,
Oh, F is the antiderivative of F prime.
it's just an antiderivative. So this
That wasn't meant to be silly. That's what it's called.
Okay.
That was. It sounded kind of odd. Kind of. I was teasing you, but no. It's just that's what it's called. Anybody else?
So, did you go backwards from F, like F being the derivative of
Something else. The antiderivative of F.
Is it ever on the excess?
It doesn't have an official name or an official symbol. However, in some AP problems, they will tell you this. They'll say, we're going, and I've seen this on calculus videos by lots of other teachers as well. They'll say, oh, we're going to say that capital F is the antiderivative of small f. That's not official, that's just something that is done.
So then F would equal, or lowercase f would equal capital F prime.
Correct.
Wow.
It's all just relative.
Right.
So it doesn't, yeah. Or-
capital F prime. Would it just be capital F?
No, because if capital F is the antiderivative of small f,
Yes.
and I take the derivative of capital F, I'm going to get small f.
Oh,
She said that capital F prime must be the same thing as small f, and that would be correct.
okay, I got it.
You're good. Come on. Okay.
Can we look at more problems that go straight from F to F double prime, like
Find one for me, Caden.
26, 27?
Stop the video. That's on.